It's Mr. Chu, and here's what you're going to learn today. By the end of this video, you should be able to derive and apply properties involving side angle relationships in a triangle. And here is video 2. If we examine the diagram, it looks like we're given angles. There are some markings for angles, and then the letters denote sides. So it appears as though we have to arrange the unknown measures of the sides from greatest to least. So that means from the longest to the shortest. Now, if you recall, the side angle inequality conjecture, it stated that in a triangle, the angle opposite the longest side is the largest angle. Additionally, in a triangle, the angle opposite the shortest side is the smallest angle. So that's going to help us here. We're going to look for the biggest angles, and then the sides across from them will be the biggest sides, and then the smallest angles will be across from the smallest sides. So what I'd like to do first is I'd like to write down a few things that we do know based off of different angle markings and then things that we know from the triangle sum conjecture. So if you noticed, we've got an angle here at 48 degrees. It has one tick mark. In the diagram, we also have another angle that has that same tick mark, so that must also be 48 degrees. There's a couple things that we can do from here. I'm going to look specifically at this triangle. There's a 90-degree mark. There's a 48-degree angle that's marked. So that means that the sum of the interior angles here, so that's going to be the 90-degree angle plus the 48-degree angle, plus I'm going to use x for this angle. The sum of these angles is 180 degrees. So we're looking for this missing angle measurement. Now when we combine, we get 138 degrees plus x is equal to 180 degrees. And to solve for x, we'll go ahead and subtract 138 from both sides. And we wind up getting x to be equal to 42 degrees. So that means that this angle here is 42 degrees. We can do the same thing for the other triangle that we see. We've got the triangle that is made by these three sides. And with that same idea, we'll go ahead and find the missing angle measurement. Now keep in mind, we're looking for the angle measurement because we want to find out which one are the greatest measurements and which one are the smallest measurements so that we can organize the sides from greatest to least. So we have a 48-degree angle, a 45-degree angle, and I'm going to use y for a missing angle. And we know that the sum of the interior angles of a triangle is 180 degrees. So when we add these together, we get 93 plus y is equal to 180. Subtract 93 from both sides, and we get y to be equal to 87 degrees. So now we have to take a look and decide which triangle has the larger sides, and then we can arrange them from greatest to least. Now, if we take a look here, we've got the pink triangle on the bottom left, and then we also have the purplish blue on the right-hand side. It appears as though the triangle on the right side, so the blue triangle, is larger than the pink one. So the largest angle here is going to be this 87-degree angle here, and the side opposite is measured D. So that means that side length D is the greatest. The second largest angle in this triangle is the one that measures 48 degrees, and the side opposite this angle is side length marked E. So then E is the second greatest angle. Now from there, the smallest angle in this triangle is the 45-degree angle. So this angle across from this angle is side length measured C. So C is going to be the third greatest length. And then we can start looking at the other triangle. So we have a 42-degree angle and a 48-degree angle. Which one is greater? Well, 48 is biggest, so that means that the side length across from 48 is going to be the next largest. So that's side length B. And lastly, we have the smallest side, A. And there you have it.